Hello, warriors. This is Miss Lemons, and today we're going to be talking about how we calculate delta T, or change in temperature. So, remember, delta T, delta being the Greek symbol for change, and T, capital T, being the symbol for temperature. Therefore, delta T is change in temperature. It's calculated by finding the difference between the final and the initial temperature. So T final, or TF, is final temperature, and the initial temperature is TI of a system. So the formula that we use to calculate the change in temperature is delta T equals TF minus TI. TF being the final temp, TI being the initial temp. Now, it is important to know that this value can be negative, and that makes sense. If we're increasing in temperature, then we would have a positive value. If we're decreasing in temperature, then we should have a negative value. It's also really important that you don't mix up and T initial, that you do have T final minus T initial. So let's go ahead and just practice calculating delta T. The temperature of a system is increased from 10 degrees Celsius to 14 degrees Celsius. Calculate the change in temperature of the system. So if we go from 10 degrees to 14 degrees, our initial temperature is going to be 10 and our final temperature is going to be 14. Minus 10 to get positive 4 degrees Celsius. This number tells me that we have increased the system's temperature by 4 degrees. Another example, a system absorbs heat energy from the surroundings, leaving the system at 46 degrees Celsius. The change in temperature is 15 degrees Celsius. Calculate the initial temperature of the system. Okay, so we are given a few hints here. It says that the system absorbs heat energy. So we know that it's going to be increasing in heat energy, which is directly proportional with temperature. If we increase in heat energy, we're also going to increase in temperature. So our final temperature should be an increase or positive number. It tells us that we're leaving the system at 46 degrees Celsius. So that means our final temperature is 46 degrees Celsius. Then it gives us a little more information. It tells us that the change in temperature is 15 degrees Celsius. So we only have the change in temperature and the final temperature. And using those two values, we can calculate the initial temperature. So you would take 15 equals 46 degrees Celsius minus T initial. A little bit of you would subtract 46 degrees Celsius from both sides, and then you would divide both sides by -1 to get Ti by itself, which would give you a positive 31 degrees Celsius. This makes sense because you're going to end up with a positive value at the end because we are absorbing heat energy. Therefore, we should have a positive heat value, positive temperature. Okay, and then finally we have a system is cooled from 146 degrees Celsius to a temperature of 84 degrees Celsius. Calculate the change in temperature. We're starting at 146 and we are subtracting it from 84. We're ending at 84 degrees Celsius. Now this is where a lot of students actually mess up and they flip-flop the order in which they're supposed to subtract. We get really used to taking a small number from a big number, but in this case, we're actually removing 146 degrees from 84 degrees Celsius. So our change in temperature is going to be -62 degrees Celsius. Yes, you can have a negative temperature, and this makes sense. A negative temperature tells us that we are losing temperature. We are decreasing in temperature. And if we're decreasing in temperature, we are also decreasing heat energy, hence why the system is being cooled. So your heat value is negative. So the difference between negative and positive delta T. A negative delta T tells you that this, for instance, the system is releasing heat energy into the surroundings. It is losing heat energy, so it's decreasing in temperature. Therefore, a negative delta T. And so there are a few hints or keywords that I would look for when I'm looking through these word problems. Oops. Okay. And there's a release, exothermic, cools down, cooled, decrease. Now, some of you might be thinking, but wait, Miss Lemons, exothermic? Oh my goodness, like a log that's on fire, that's hot. It doesn't cool down. You have to remember that the system would be the log, and it is releasing heat into its surroundings. So the log itself is cooling down because it's releasing heat. Positive delta T would be the opposite. The system absorbs heat energy from the surroundings. It is gaining heat energy, so it is increasing in temperature. Therefore, it would have a positive delta T. Some words you should look out for would be gain, increased. These are all good words to help you predict that your delta T and your Q value will both be positive. So at this point, we've encountered a number of new variables or symbols. It's really important, again, that you know the symbol and how it affiliates with its unit. So lowercase m is in grams. The symbol is lowercase q, that's measured in joules. Delta T is in degrees Celsius, etc. If you're struggling with these, you're going to continue to struggle for the rest of the unit. So please make sure you take a moment to take a look at the Quizlet that I've created for you so you can stay fresh on your variables and units.